the whiteboard, and so today we are going straight to the implementation. And actually today we are going to complete, we are going to partially complete our shell, right? Yeah, so actually it's going to accept some commands, then it will just process them for us. That's what we are going to do it tonight. Yeah. Okay. So let me share my screen. And voila, we have it here. All right. Okay, so yesterday we were implementing this. So I'll move all these files to our tests, right? So that actually those that weren't present yesterday, at least we'll be able to take them through the basics, right? Yeah. Right. So let's first of all create our basic files. So first of all, it doesn't matter how you name your file, all right? So I'll just name it main.c and main.h, right? And we have all the files here, which is main.c and main.h. Okay, so vi into main.h and all the necessary header files, or let me say the libraries that we'll need for the time being, we'll just include them in here. So first of all, we'll add our standard input and output header file. So stdio.h. And yeah, so for now, we'll just include this, right? So let's go back. We'll go to our main.c file. And yesterday, we actually talked of trying to reduce the lines of codes in each file, right? So let's try and complete everything. Then after that, we'll try and split those into separate functions. Okay. So I'll include my header file. Then my main function. So for now, it's going to accept a void, right? It's not going to accept any parameter for now. So first of all, we know that our shell actually, when the shell runs, there is a prompt, and that prompt is visible in our terminal, right? Which is actually always waiting for us to input something. So even the beginning of your code, the only thing, or the basic thing that you're supposed to start with is just how your program should print its prompt on the screen, right? So we just declare a particular, let me say, yeah, a particular data, or possibly a particular variable here. We just name it prompt. And it doesn't matter how you want to name it. But I think when I read the concepts, let me say, yeah, the concept page, for example, I got to actually understand that you're not supposed to use redirection characters. You're not supposed to use semicolon. And we are not supposed to use punctuations here. But apart from that, we can use any other thing. And it should actually be a word. Okay, so it doesn't matter how you want to actually name it. It should explain itself. So just yesterday, we actually named our shell, right? And after that, we just add our dollar sign. Then we put our space here. That's because we want our prompt to be nicely, or possibly our shell to actually print its prompt nicely on the screen, right? So that there will be enough space, or possibly there should be a space between our prompt and the input that the user will type. Okay. Then, so actually, I also went through the requirements and I saw that we are supposed to use the write function, right? But not the printf function. So, in other words, we can actually implement the write function in here. But for now, let's just implement the printf, all right? Then maybe when we want to go much more detail, we just implement our own write function, which will just print a string for us. Okay, all right. Or in other words, we can just start doing them here. So I'll just say int underscore putchar, all right? I know that putchar actually accepts it. Then we'll return write, okay? And write will print to the standard output. Then the buffer will be the address of the character. Then it's just one character that we are printing out. So that's it for our write function. Then we want to actually implement, okay, putchar, sorry. So we want to implement a string, all right? That's a function that will actually print a string. So you can just say int underscore print string. Then it will be a character pointer, str. And we will just raise our loop. So I'll just say int I is equal to 0 and counts is equal to 0. All right. Yeah. Then after that, we'll just we'll raise our while loop. Then we'll say while str, which is the first index of I, or possibly the first the index of string is not null. So possibly each and every single character in our string is not null. So in case if it is not empty, then we want to implement our putchar function. So just say count that's equal to right. Yeah. The index I. Then we need to increment I too. So I'll say I plus plus in here. Then after that, we just return our count. So return count. Okay. Then since we are implementing multiple functions here, we can actually decide that, hey, let's just take this prompt out. But anyways, let's just go on. So these are just by the way. We just need to utilize them here. That's all. So we just call our print string function. So we just say print string, right? Then we'll pass in prompts. Right. Then when we were implementing that too yesterday, we also got to understand that getLine is a function that actually accepts an input from the user. And getLine actually accepts 3 arguments. All right. So getLine is spelled this way. And it accepts 3 arguments. The first argument is the buffer as is it a pointer? Okay. So it actually accepts the address of what? Of the pointer, which is the buffer. which will point to the string or possibly the string that the user will input into our system or into our shell. Then the next two is also going to be the address of what? Of the size of our buffer. So buffer size. And the last parameter is going to be where do we want to collect or possibly where do we want to accept our inputs from, which is going to be the standard input. Standard input, all right? And that is it. Okay. Get my buffer. So we've not declared our variables, buffer and buffer size, right? So buffer is actually a character pointer. So I can actually declare it here. And buff size is actually a size underscore T data type. So I'll need to declare it separate. So size underscore T, then buff size, right? So I think that's it for now. And we can decide. Yeah. Okay. Yes, sure. Thank you. I think yesterday I made this same mistake. Almost forgot about that. Okay. So one thing we want to do is that we want to actually implement our string function and we want to see if like our input is actually working. So whatever that we accept from the user, will actually print it out on the screen. All right. So we just say buffer, right? Let's say buffer. Then I think that's it. Let's return from our main function. Yes, thank you. So, and one thing too that I'll never forget is that we will need to free our buffer because getLine will automatically or possibly dynamically allocate a space for buffer, right, which will store the string. And I think one of the important things that they highlighted in the concept is that we have to make sure that our program, there is no memory leak in it, all right? So it should manage space correctly and perfectly fine, right? So we have to make sure that we free our buffer, right? Yeah. So that is it. And buff size is equal to 0. Now I can even decide that, hey, let me just initialize this to null, right? Since it's a pointer, I can decide to initialize it to null so that when we just pass in our inputs, it will then be reinitialized. Okay, so I think that's it for now. Let's save our program, GCC. Okay. Oh, I forgot to add this. Wow. So I'll go back to my main.h file. And I'll include it in there. Yeah. So I think uni std. If somebody's asking whether I'm sharing my screen, he can't see it. Okay, so I'll try and reshare the screen again as soon as possible so that you'll be able to see. Yeah, I think he just he just came in. So maybe okay, don't worry. So maybe you can leave the huddle and rejoin again. All right. Yeah. right? And let's run our code. And let me just say hello, all right? Now we go hello and it's exited. And yesterday we did the same thing and it's printing perfectly fine for us. Okay, so that means that our get line is working, our train string is also working, and our prompt too, we can actually see it here. Now let's implement how our program can actually utilize the, let me see, reprompting, right? You see that, for example, if I type ls, it's execute this command, then the next prompt will pop on the screen again. So that's what you're actually going to utilize, so that when it executes the code, it doesn't exit. Right? So we'll go back to our main.c file. Then, without any stress, we just have to implement our while loop. All right. We just say while one. That means that while it's true, then we want to call our while function. That's our while, all right? Our while loop. Yeah. Okay. All right, let me try and release every single buffer after the while. Once the while loop is done executing, and let's save it. Let's go back. Let's recompile source code. Let's rerun our code. Hello. And see, it's now reprompting us to input something. I'll say hello again. Okay. So they're saying that double free detected in Tcache. All right. So that means that I'll need to actually free it after the while loop, but not inside it. All right. So along the line, maybe we need to. And let me recompile. Let's run our code. Let me say hello, right? Hello again. Let's see. Even if I type hello, good morning, right? It's evening. Yeah, it's like it's printing the entire string on the screen for us, and it's actually reprompting us to input a command. So we are done implementing the reprompting and actually accepting an input from the user. Now let's try and raise a condition where, in case if the user inputs the exit status, that's issues the shortcut, which is the control D, so that it will actually exit. Because I think in the requirements, you are supposed to implement that. So let's actually, if I type exit, it's not exiting. Okay, so and if I control D and see what is actually happening, so we are getting ourselves into trouble just by typing control D. All right. So let's go back and our main.c file. Let's try and fix it. Okay, so we are returning count, and yeah, because yeah, I'm implementing I++. All right. Okay. So now,
Hello, Emmanuel.
hello.
Yeah, I have a question here. And which line of code is responsible for control C?
Okay. So actually, what I know by control C is that control C is just like a default exit status, all right? No matter the program that you're running, if you just press control C, it will actually automatically exit, all right? But in the requirements, we are supposed to just implement the utilization of the control D command, all right? That's the reason that in my shell, when I actually executed the shortcut, which is Control C, it exited it. But I haven't implemented it in my code, but it actually worked. But ALX wants you to do it so that you actually understand that. So they are saying that we're supposed to implement the Control D shortcut, right? Yeah. So Control C, we're actually not talking about that now. Yeah. Please, I believe it's cool. All right. So now once we accept an input from the user, we want to actually see whether what the user gave to us is actually -1. We know that, okay, when we ran the man page, we got to know that get line actually returns the number of characters that the user passed. All right. So the number of characters in our buffer, when we enter hello world, getLine will automatically calculate the number of characters in our buffer and it will return it. All right. So if getLine is returning it, then that means that, and there is another condition too, or possibly there is another side too. If in case we issue the end of file command, which is the Control D, getLine will actually return -1. That means that we can grasp that loophole and we can utilize it for our Control D. So that's what the man page actually told us about the getLine function. So I will implement a variable here, and I'll just say n_cars. So that's number of characters, right? Why am I still typing? Okay, so number of characters. And we know that getLine is having the data type of SS size T. That's S size T, right? S size T. So n cars should be assigned. So now once you're done, we just have to raise our condition. If n_cars is equal to, or possibly, yeah, it's actually equal to -1. Then we want to return -1, right? That means that we want to exit from our program, right? So we can actually decide, let's try, or let's utilize a printing. Okay, let me see my, okay, so this is actually a character pointer. All right. That's called print string. Then let's say exit. I think we are good to go. So let's save our file. Let's recompile it. Let's run our code and we say hello. Okay, it worked. If we type exit, nothing popped up. If you say cd, okay, it's still printing it out on the screen. Hello world. Okay. Now, if I hold Control and B, see, it's printed exiting shell and it's exited from there. Wonderful. That means that we've implemented this as part of the requirement. Now, the next thing that we are going to do, how then can we allow our shell to accept a particular input as a command? And if that particular command exists in our path, it will execute it for us. All right. So there is one function that we know as execv. All right. And yesterday we also learned about fork. Okay. So fork actually is a command, or let me say a function that actually allows, or possibly it starts a child process. So let me put it that way. So fork actually starts a child process. All right. And fork, when it executes, it it returns the PID of the child process. And exec v works in a unique way. When exec v is executed, it overrides the calling process. So for example, if we run our shell and we call cd inside our shell, which is cd is actually a command, exec v is the function that is actually going to retrieve cd and it will execute it for us. And at the same time, exec v is being called. So once exec v is actually running, it will override our shell. Okay, so that means that our shell will exit once it's done. Let me see, executing the CD. All right. So that's where we also have to implement another function we call wait. So let's box on and let's begin dealing with that. Okay. So let's go to our main.c file. All right. So, yeah. So we are accepting buffer and we want to actually just accept the command and we will just execute the command for the user. So first of all, what is the next thing that we need to do? Okay. All right, so now we accept the buffer. Okay. So now we'll just let's start calling our fork. Okay, let me declare our process ID here. But before that, let me go back for confirmation purposes. Let me go back, use the man page, and let me read about the fork, all right? So that we'll know what it actually returns. So fork is actually of the type PID underscore T, and it's being found in the library, which is unistd.h. And fork doesn't accept any arguments. So it creates a new process by duplicating the calling process, all right? So the new process is referred to as the child process, okay? And the calling process is referred to as the parent process, all right? Cool. That's it that we need now. So let's go back to main. Main.c. And since fork will be returning our child PID, let's declare that it's PID underscore T, if my memory serves me right. Then we just say child ID, right? Okay, so C H ID. All right, so let me make it that's definitive. Okay. Yeah, it should define itself. All right. Now, we'll decide to call the fork command out here, right? And fork actually doesn't accept any arguments. And it will actually return the ID of the child process. So we just have to call our child ID variable so that it will be handed over to it. Now remember that when we were utilizing the fork, we raised a particular condition. We were checking to see if the fork actually worked or it didn't work. So first of all, we'll check to see if our child ID is actually less than 0. So let me just say less than 0, right? Yeah, less than 0. Less than 0, then we want to actually, so let's implement our print string. I'll say, let me just print this out. And now, else if our child ID is actually equal to 0, right? Then we want to call our execv function, okay? Then execv is actually going to accept so many parameters. I think 3, right? Yeah, it's going to accept 3 parameters. Let's go back. As man execv. Okay, so execv actually executes a program. It's also found in the unistd.h. It accepts 3 parameters. So we have the path name. We also have this one, is it agv? All right, so we also have this, which is actually the argument. We also have the environment. So actually this should be nullable. This should also be nullable. Okay. So when we xv executes the program referred to by path name. So by utilizing xv, that means that when we implement it as simple as this, the user will need to actually enter the absolute path of the program. So for example, if you want to execute ls command, you just have to type /bin/ls, all right, for it to be executed. And xv will actually do that for you. Okay, so this causes the program that is currently being run by the calling process to be replaced by to replace with a new program with newly initialized. Okay. All right. Okay. So we are actually going back to our main.c and let's begin implementing it here. Okay, so is it v? But there are some variables that have also not initialized. One thing is we have our buffer here where the user will actually input. Okay, yeah. So let me try and add up some additional variables. Okay. So fz. So we have a character pointer. We also have a character pointer, and we also have a character pointer. Okay, so all of them are character pointers. So let's try and implement our arguments here, or particular parameters here. So let me just say int c and r and yeah, onto will be car. Let me just say env. All right. but we are currently not utilizing this one. So let me just typecast it to void for now, right? Now let me pass it to our, where is our Isaac V? Okay. So currently I'll pass in our buffer, all right? So buffer with the index 0, then our agv, then our env. And after our if else, we just have to raise our else condition. Then, yeah. So we just have to raise our else condition. Then let's implement our wait. And I think wait to man with a wait. So wait can be found in sys/wait.h. These are also its brothers and sisters. So it waits for what? For a process to change its states. And yeah. So saying that, all right. Yeah. Stephen, you're answering all the questions, right? That's cool. That's cool. Yeah, that's cool. So that is wait for us. Our wait system calls suspend extension of calling thread, whatever, blah, blah, okay. Right. Okay. Yeah. So Stephen, I'm adding up our correction. Okay. I think that'll be it for that. Yeah. Okay. So let's try and rate this another condition too. In case if whatever that the user will pass, it is like it doesn't exist. All right. Yeah. So that's will actually raise an error that hey, please, that command that not exists. Yeah. So let's try and raise a condition again. So just say if, yeah. So I think this will even be simpler. So if, then we just equate it to a 2 -1, right? Because a zig v, yeah. So in case if it doesn't exist, then a zig v should just implement our print string for us. Then we'll just say that print something, which is actually going to be the name of our program. Okay, sorry. I'm not using printf. I'm not using printf. Okay, so let me just implement printf. I think this would be better. So I'll just say just add the name of our program, right? Then we just say command does not exist, right? And let's add a new line character. So just pass our buffer, the index 0. And okay, now what if it actually also exists? What if it actually also exists? Yeah, Stephen, Stephen, was that you? Can you repoint it back again? Let me see what you wanted to me. Yeah. Oh, I was seriously okay. Who borrows his or her printf? We want to actually incorporate it into our program. Okay, so when we look through the weights, I don't know whether did we check the weights? Yes, we did. So when we check the weight, we got to know that actually weight accepts the status, right? And it's also a nullable status. It's actually a pointer. So since a pointer, we need to pass status as what? As an address to it. Okay, let me see. All of these system calls are used to weights. Okay, all right. I believe we've read all these things. Okay, now let's go back to our code. Now we called weight out here. Actually accept status, right? I'm just saying. I remember we've also not declared status anywhere, right? Status
Yeah.
does not exist in our case. So we need to make sure that we also initialize it out here. And it should be an integer data type because we know that status was actually an integer, right? So was somebody asking a question, please? So I think this should be it for now. I believe this should be it for now. Um, okay, print. This one is still going to print something. Okay, don't worry. Let me um comment it out instead of trying to clear it out. Actually, I know that one of the recommendation is that when you're actually coding, you need to use hard codes. Try and print your code for you to know where the possible errors might be. Okay. Now we have our fork. We are returning. Okay. Okay. So now we'll raise a while loop. We'll print our prompt. We'll accept an input from the user, and we'll return the number of characters in case if it is the end of file argument that the user passed, then that means that it will return -1. Then we'll just print this, we'll exit from our program. All right. And if it's actually not the end of file exists to us, then we'll just have to bypass this if condition. We will call our fork function. Then we'll return the PID to our child ID variable. Then raise a condition and we see if it is actually less than 0, then we'll just say fork what? Failed. Yeah. And even if you are exiting, we are still not releasing the buffer. Our program will close without releasing the buffer. Wow, I almost forgot that. Okay, so I'll just call free and right. And even for this one to the same thing, right? unless possibly our
Hello.
program, if it
Hello.
runs and yeah, hello.
Sorry for interruption. First of all,
Okay.
I like your presentation, but unfortunately, I may not continue with you. I have another meeting. I just a question. I was just waiting how you'll implement your own primitive or use the right function. Is there a way you can, because I think from the requirement they do not allow you to use the direct printf.
Yes.
So can you use
So
the right function or implement your own printf?
Um, so actually, the requirement says that you're not supposed to use a printer function, right? So the reason I'm actually using the printer function here is just so that I'll be able to print the name of our program out. But if you also prefer, we can just take this out. There is no harm, like there is nothing wrong if we just print command does not exist out without printing the name of the command or possibly the input that the user passed. All right. So we can just pass it in there without any error. So I'll just say print string, right? And this will not cause any harm. Let me add my underscore. I can decide to take this out. I'll also take the buffer out, right? And believe it should work fine. Yeah. And I left a space here. So actually, even when you guys like when the printf project was we were implementing the printf project, it wasn't easy at all. So if you really decide that you want to actually implement your own printf function, then that means that there should be a way that you have to merge your printf function to this particular code. All right. And it's actually going to make your files bulky and very huge. All right. So ALS just said that we can actually implement the the write function. Okay, so any way that you can actually use the write function to write something on the screen, you can actually go by it. All right, yeah, that's cool. So earlier from the beginning, we just implemented our string function just to be able to print a string for us. Okay, yeah, and that's what we're actually using throughout. Okay,
Okay,
okay.
nice. I really like your presentation and your flow of code. Oh, I wish the session could have been recorded. I just have another meeting for our project. I mean, code 30.
All right. All right.
Yeah, we also have we are currently having a team project as well.
Yeah.
Okay, so bye.
Yeah. All right. So if we actually check our code, see now currently our line of code is almost getting closer to 70. And we know that the recommended lines of code in a function, it shouldn't go beyond 40. Right. And maybe I believe maybe because we have these multiple functions here. Yeah. But anyways, let's save our file. Let's exit. Let's recompile our code.
Sorry. I have a question too.
All right. Okay.
Yeah. Yes, the exec VE is for execution of vector environment.
Yeah.
And so why you are taking the buffer of 0? Because buffer holds the user input string, and that's not a command, like that's not a program. So get line, it is the user input string. So what if you change the buffer of 0 to another like pointer, like a path, a built-in path, like argv of 0? If you do that,
Yeah.
there are
Okay.
two ways.
All right. All right. So I believe that's actually what I had in mind. So let me implement that too. So I believe we have a V here. And okay, don't worry. Anyways, we'll still be fine. Still be fine. So let me just try and re-change this out. Okay, this is actually a double pointer. Okay, let me just say arg with our our square brackets. Then let me just make it a pointer to an array. All right. Yeah, I think this will clear possibly the error that I'm encountering right now. Yeah. Then what I will just need to do is just reassign our buffer to it. So before my fork, okay, so before my fork, I'll just say arg v, and that's arg with the index 0 is equal to our buffer. And maybe I believe this would possibly fix that on our behalf. Let's just hope so. Yeah. All right. I believe this is cool. Okay, let's try it and let's see. Let's just cross our fingers. Okay, so we have wait, implicit declaration. Ah, okay, yeah, I forgot to even add sys/wait.h. So main.h. All right. So our compilation have worked. Now, if I say hello, now see, command does not exist. If I type new, command does not exist. If I type ls, command does not exist. But let's say bin, okay, /bin, /ls, okay, command does not exist. But let me try and exit. Control D, and Control D. Wow, it's actually running into an infinite loop. What could be the possible problem? All right, I'll try and fix that. So let me say /bin. Yeah,
it is successful. It is successful because your argument is like argument vector is null. Null means control C is null. So keep working like, or when you hit enter, it works without just any.
Okay, so we are going back. Oh, I'm actually passing arg v. Let me pass arg. Yeah. Okay, so this should be arg. It should return -1. Then it'll print command does not exist in case if it returns -1. All right. Else we want to call our wait status for it to wait. Then we'll free our buffer. And okay. And from the top here, constant character arg with it, that's an array all now. All right. And status, we have status here, which is actually an integer. Okay. And let's recompile again. Let's run our program. Okay, /bin, /ls. Okay, now we are getting command not found.
Are we not supposed to can repointing zero to buffer? Is that valid? Okay, maybe I don't know. Are we supposed to like copy it into that place so that it will like allocate memory for that pointer enough to hold buffer?
Okay, so I'm coming. Yeah, you said add V.
Like no hags, like where you have hag 0 equals to underneath, yeah, where you have hag 0 equals to buffer. So how about hag 0 equals to maybe stro dupe or stro copy buffer? So that will like copy buffer into that place. You know, at the moment, hag 0 is just a pointer, as it were. So you've not allocated space enough to hold even 1 byte. So probably we'll use stro. I don't know if stro copy allocates memory, but I'm sure about stro dupe.
Okay.
No, stay that same line where you have ARG0. Yes, sir.
I want to keep this out first because currently we are still not using ADV along the line. So let me take this out first. Then we use the ENV. Okay. So this, you said we are supposed to use string dump, right?
Yeah, and it's like string copy or dupe. Yeah, I think dupe. Let's just go with dupe. Yeah. But you have to free that stuff later though.
Okay. Then once you're done, let's go back to yeah.
I think this should work.
Okay, so let's go back to our header file and let's add our string library. All right. Okay, now ls, okay. Cool. All right. Now being /ls. Okay. And also getting command not found. What could be the problem that we are facing that we cannot fix it out? Man, this is something. There's actually something.
What are you expecting? Like, what are you going to do? Just tell us first.
So, is it that we are actually testing our shell with our local shell that we're actually using? We want to actually see that it's working, right? Yeah, it's actually working. But currently, it's not really happening. Oh, hold on. Yeah, I forgot something out. Yeah, so actually, since it is ls command that we are inputting, we are expecting that ls should work, just like the same way, bin /ls. So it's like printed the content of our folder on the screen for us. Yeah, so it should work. Even if we type bin /echo, and maybe if I add, if which one is the simplest, okay, main.speech. Yeah, it's like it's echoed the name of our file out. If I can also say hello world. Sorry. Right. And you see that it's actually working. Just like you've entered echo and you're saying hello. I printed it out. Yeah, so that's what we actually expected from our program. So with much we do, yeah. So one thing too is that there is something about execv. For it to be executed or for it to execute, there should be possibly our buffer should be terminated with what? A null terminator, or possibly with what? with a null character, right? And that's what ExecV is actually expecting. So I believe maybe if I implement that, yeah, the challenge that we are facing with it's not running, it might. So I'll just say wow, then our buffer. So we just look through each and every single character, all right, or possibly each and every single character in our buffer. Then we'll just see if our character is actually the null terminator, or possibly the new line character. Yes. If it is the new line character, we want to actually just put 0 there, or possibly what? No. So let me just say buffer index I. If it's actually equal to our new line character, right? Okay. Then we just say buffer with the index I. I'm just putting 0. Okay, sorry, I've not initialized I. So let me put I in here. Where is in? Okay, so I have I. So I'm going to initialize I. I is equal to 0. Right. I believe that's it. Okay. So yeah, I think somebody told me to check the buff size. So actually the buff size is not for us to handle. All right, get line automatically handles that.
I got lost.
Yeah, hello.
Oh, I plus lost. You missed it in your loop.
Oh, sure. Okay, so all right. Thank you. Oh. I just read that this should work. Oh wow. Cool. I said it's working. Now if I type echo, that's /bin, echo, and maybe, okay, don't worry, let me see, hello world, or possibly hello. Okay, it's not working, but bin /ls, and if I add this, also not working. All right, that's ls alone will work. Which command also, yeah. So bin pwd is also working. Then and who am I? Okay, so it's working. If I hold Control D, it said exiting, but it still went back to our loop. Wow. I think we need to fix that. We need to fix that.
Yeah,
Please,
you have
any
to use
question?
break, maybe.
I think with break, it will still, well, I don't know, but okay, let's go back and let's. So this is what we are implementing, and we said if so, this our prompts, and it still goes back, and it's printed out. We are returning -1. We said free buffer, and we are printing this out. Okay. Yeah. Is it possible that we can use a break for it to close our program? No, I don't. Okay, well, I don't know, but I don't think so.
You can
Okay,
exit
there is no
zero. Exit zero.
Yes, yes. Let's try that. That's better. I think with exits, it should be a bit more clearer. Now let's recompile. Let's rerun our program and let's try Control D. Oh wow, cool. Thank you, Seth. So you see that it's actually working. All right. So all right, thank you, Mr. Pascal. Wow. Oh, okay, you're here. Man. Okay. So let's change this to out. Zero. All right. Okay. So currently our command.
Sorry for interruption, but is there anyone who can just make it clear, clarify about the exit zero and break and return a negative one?
Okay, so like clarification for that. So actually in C there are certain macros, all right, in C. So there is an exit failure. We have other so many other macros out there. So zero actually have a macro that we can actually use too, which is exit failure. All right. And return -1. We know that on every unsuccessful program running, it will actually return what? Any number apart from zero. And we know that actually if a particular program returns a negative number, it means that there was a problem with it, all right? Possibly maybe there was an encountered problem, okay? Yeah, so that's the reason I was actually returning -1, thinking that it will close the program, all right? Yeah, but it actually didn't work that, or it didn't implement that for me. So I believe the exit is working perfectly. Cool. So we just go by that. Yeah. So now we want the next thing. Okay. The next thing is that we want to actually implement, in case if we type bin/L, ls, then maybe if we add L, it should work. All right. It shouldn't tell us that command not found or command does not exist. Okay. So you see that, is it that when, if we actually implement our, if we implement this same approach, which is bin/ls, and we add -L, it lists our files in what? In a long form with all those details being revealed. And even if we add A, it will even add all those hidden files too. Okay. -L, it should print it in a long list form, and it should also add up all the hidden files. So that's what we are actually going to implement now. So go back to main C again. Right. So who can actually this way that we can actually implement. Yeah, can you please underline that for me? Okay, sure. Sure. Yes. So I believe we will have to inculcate, is it tokenization? Right. Yeah. That's where we have to we'll have to actually implement tokenizing our code. Wow, it's actually going to be something. But if I could also recall perfectly fine, we're also supposed to make sure our program should run in an interactive mode and also in an uninteractive mode. And possibly it should, example, maybe if I say echo and maybe /bin, it's a /bin. Maybe yeah, /bin /ls, all right. Then if I type it to our program, which is currently a.out, right? Yeah, should work, but see, we are seeing exiting. Okay, let me go back and let me fix our. Okay, so that means that in some way, somehow, it's printed the prompt twice, which actually is not supposed to do so. All right. I think in the example, let's say this way, echo /bin /ls, then we pipe it to our bash shell. You see that it's printed like it did ls, then it's exited. All right. So it's actually supposed to work the same way. All right. There's actually in an uninteractive mode. That's where you are piping the command to the program. And when we did that to ours, it's actually doing something else. It's actually doing something else. All right. Okay. So let me try and pick this two out. Okay. So it's saying command not found. So is it that it's actually doing something else, which we are not really expecting that. It's actually printing this and saying a.out, whatever, did all these things and test. And it's also say exiting shell. So there is one function that we can actually also implement. I think we call it is I don't know how whether it is well, anyhow you pronounce it, please. Yeah. So this is actually the name. Okay. Yeah. And we say it's used to test whether a file descriptor refers to a terminal. So our prompt will only print only when we tell it to from the terminal. So just like when we are piping the command to our program, it shouldn't print the prompt on the screen for us, but rather it should just call that program and it should just run it for us. And we don't want it to print the prompt. So that's what we use this thing to do. All right. So it's just actually a function that's we use it to check a condition. Okay. Yeah. So let's go back to our main.c. And if you go to our program, we just raise a condition and say if, right, then we just say ISATTY, right? Then we just ask that is whatever that the user is inputting, is it that we are waiting for it from the standard input, all right? Yeah. So we have a particular macro that we actually call standard input file what? Is it file number? Yeah, file number or whatever. Yeah, that's actually the name. I don't know. Okay, so we call it std in, right? Underscore. And I think it's file. Is Pascal, can you help me out here? I don't know whether it is file no or whatever. Is this so? Is Pascal here or Pascal is out?
Well, that's correct for the standard input
Yeah.
descriptor or whatever it's called. I mean, that's how it's written.
Okay, let's try that.
Sorry for the late response, please. I was busy. Sorry.
Oh. Yeah, sorry for disturbing you too. Okay, so let's say we can actually use 0. Okay, so let's use 0. Then in case if that condition is true, we just call our prompt. And we know that our prompt is just surely going to just okay, where is our prompt? Yeah, this is our prompt. So we are just going to call print string and it will print the prompt on the screen for us. So if it is not from the standard input, all right, that means that if it is not interactive, then we don't want to print our prompt. All right, so let's save it. Let's recompile our source code. Now, so let's try and typecast it. Okay, now see, it printed it out. But remember, we've inculcated this, that when it's exiting, it should print exiting shell. So let me try and remove that from there, all right? We don't want to debug it at this particular pace. If we want to debug our code at a particular extent, we will just implement it. Yeah, so that's what we actually use in the if condition to check it out. All right. So if actually we'll check and see if it is actually true, like if what is Sati is actually returning, if it is true or if it is valid, then it will just call out the prompt for us. If it is not, then we should just skip it. All right. Yeah. As actually didn't initialize any variable to it, but I just straightly passed it to the if condition. So we don't need to implement any other variable. Okay, I didn't recompile, sorry. So if you run it now, wow, it's working. All right, just like earlier, how our shell was also. So you see, it's working the same way. That's cool. Now, how then are we going to inculcate where our program can actually accept options or possibly, let me say, parameters from the user, all right? Yeah, so that's what we are actually going to implement from there. Okay, now we are back to exhibition. Now there's a moment that we need to also incorporate the tokenization. Yeah, I believe so. Okay, we need to implement the tokenization. Okay, and earlier here also so assigning it to null. Okay, so hold on. So really we don't even know the number of argument that the user is going to pass. But let's presumably Memory management. Yeah, okay, let me just use 10 as a small number. Okay, maybe this will be better. Then where we want to tokenize our string. So if we accept an input from the user, okay, so let's go back to the man page. Let's read about the str talk, which is the string talk, right? Okay, so is Mr. Pascal here? I don't know whether I'm actually getting this right. Please, are we allowed to use the string talk command? That's the string talk function. Are we allowed to use that?
No.
Yes.
You're not allowed
Yeah.
to use the extracts. Okay, I think yes. But at a point, you have to
Yeah.
write your own.
Yes,
but,
I think.
But I think you're allowed.
Yeah, but
You're
I think
allowed to use it.
one of the tasks you have to implement your own.
Yes,
Yeah.
exactly.
Yeah,
You're correct.
But actually, for that, we are not going to do it here. They're not,
That's true.
they're not going to implement our own built-in string talk command in here. So, okay. So I think that's cool. All right. So there's our string token, and it says we use it to extract tokens from strings. So the entire string will be split into tokens by using something that we call a delimiter. All right. So the delimiter, you would rather have to specify whether you want to use comma, whether you want to use colon, whether you want to use a semicolon to denote your delimiter. It's all dependent on you. But in our case, we know that every single input that the user will pass, it's actually being separated by what? By a space. So our delimiter, we're actually going to use a space to denote our delimiter in our case. And our string talk, we know that it actually accepts a character pointer, right? And the delimiter too is also actually a character pointer. All right. So let's see what string talk returns. Okay. So string talk and string talk and the other brother functions returns a pointer to the next token. All right. Okay. If there are no more tokens, yeah. So or now, if there are no more tokens, so the last, let me say, the last return is going to be null. If no more, like there are no more extra tokens out there. Okay. So let's go back to our main.c file. And string talk is actually found in string.h. So we're actually not going to add that to our source, to our header file, because we've already included that. Now, since we are going to implement string talk, we want to take away the string down, then we'll utilize string talk out here, right? And our delimiter. So let me use delim. Remember, our delimiter, we've not initialized it. So we can decide to even add that to here. So let's say delim. Okay, so it's actually a character pointer. So delim, it's equal to our empty space. Let me add a new line to it. All right. And where is it? Okay. So string talk, our buffer, then our delimiter. So now, after we do this, okay, I don't want to make it a hard code. So let me implement a variable in our agv, right? So let's go back again. Let's read a
Exactly.
string talk in detail.
You can
So
just, you can
that's
use the as v anyway.
Yeah. So you see that if we check the description, we can actually see that string talk function breaks a string into sequence of 0 or more non-empty tokens, right? On the first call to string talk, the string to be passed should be specified in string. So that's what we've done, all right? So we've passed our buffer to string talk plus the delimiter, all right? And we are assigning that to our v. And currently want to change the, okay, don't worry. So v, which is actually the first index. So in each subsequent call, that should pass the same string, all right? str must be null. So that means that in subsequent calls, since our token, in case if it's going to contain multiple arguments, in subsequent calls, we have to make sure that we pass str as what? As null. That means that instead of passing buffer, in our case, you're supposed to pass in null. All right, plus the delimiter. So automatically, this null character will just tell the token that, hey, please just assign the next token or possibly the next word to this variable. And let's go back to what, or possibly let's go to what, to the next word until it encounters what, the null character. All right, or possibly until it encounters what, the end of line. That's the new line character. Then it will return null as the end of our token. All right, or possibly the end of our string. So that was what we are going to implement in there. Is the explanation cool? Or we need to add more light, throw more light into it? Exactly. Okay, so if that is so, if Seth, please, is there any questions on? Okay. All right, so I think there are any questions. All right, so we'll go back to our main.c file, and we called string talk out here. And as we already read, we could actually see that we need to call string talk subsequent times. And for that, we need to pass null instead of buffer, right? So we'll just raise a condition. Let's say we still use our while loop, all right? And we'll just say arg with the index. And since you're going to look through each and every single token, and remember, we want to actually we want to be able to pass whatever option or parameter that the user will pass in addition to our commands. We want execv to actually be able to execute them too. So we have to make sure that these subsequent options should also be inclusive. So I actually have int I is equal, okay, let me use another variable. So I'll just say maybe j could be better so that it doesn't mix up. So I just say j is equal to 0. Now I can decide to pass j here, then here too I'll pass j, right? Then after that, I'll just call my add with the index j. Then we will call our string talk command then we'll pass in null plus a delimiter. These are the subsequent calls. That's where we are passing the null. Now, I need to also increment j, right? Yeah. So j plus plus. Okay. Cool. Now, we also know that after or at the end of our tokenization, all right, there have to be like our last token should return, or possibly it should be null. Okay, it should be null. So automatically we know that string talk returns null as our last token. All right. In case if there are no more tokens, it returns null, as you read from the man page. Okay. So as you read from the man page. See, that's from there. That's so yeah, so it should be specified in each subsequent call should pass the st that's the null instead of str. Subsequent calls, okay. Yeah, I think the return is here. Yeah. So you see that the function returns a pointer to the next token, or no, if there are no more tokens. So when we get to the end of our token, it will actually return null. Right? Yeah. Cool. That's wonderful. All right. So now I believe that's it. Let's go back to our main. Oh, actually didn't exit. Okay, so where is that token? Okay. Yeah. Now what do we need to do next? Okay. I believe we are done, right? For this. Yeah, I believe we are done for this.
Yeah, it seems so.
Right.
Yeah, looks good.
Yeah. So let's save it and let's recompile. Oh man, I didn't add my semicolon. So main.c and day, but to add a semicolon. All right. Now, if we type ls, it's still not going to work. All right. Okay. bin/ls. What could be wrong? All right, no problem. All right. Now, let me say bin/ls. Yeah. So vi main.c.
So can you check the value of the arg-o if it's actually getting the right token? The arg-o.
Yeah. So can we decide to print it out so that we see or
yeah, that's yeah. I think print it out or something like that.
okay. So let me put printf here. Yeah.
Okay, you noticed something.
Yeah.
Now you said at J and you said at J again, like you assigned it twice. Did you notice it? So you're supposed to increment it before you assign the second arg j.
Yeah.
You get.
Oh.
So you can
Oh.
try that. Yeah.
Oh. Okay. So let me try and okay. I think this two will also be better. Okay, this will increment before it will run it out. All right. But in other words, we can still decide to print this out. So I'll see what will actually happen. So GCC now bin /ls. Okay, it's working. Oh yeah. So our printf is actually working. Our debugger is actually working. It's actually printing. That's back for us. So let me go.
So I believe if you pass the flag now, it's going to work.
Yes. So let me take this out. Then if we go back GCC, all right. Bin /ls, then L. Wow, it's working. All right, now bin /ls, then hyphen A. So bin /ls hyphen LA. It's working. All right. Now let's try and use I think cat, right? Okay. Then it's and main.h. All right. So that is it. We can also decide ls -l with our tests folder. Wow.
Allows a complete shell. Nice.
Yeah. So Seth, how many hours? I believe our hours is up, right? 2 hours, right? Yeah, so we are almost. You said I can do 1 hour. Man, please, please.
Mr. Emmanuel, let us go deeper and deeper, please.
Seriously.
Deeper, yes.
Man, my mind is actually breaking out here. Seriously. Okay, so any questions so far? Any questions so far? Is there any function, any let me see, any algorithm that we implemented that's possibly understanding is a little bit?
Hold on. Please, I have a question. I have a question.
Okay.
Okay. Please, can you go back to the code?
Right.
Okay. At that point, okay, get line, yes. Okay.
Get line.
Okay. Okay, go to the exec v. Exec v. Okay, now this function exec v, it's not that we have actually called it before comparing it, if it is if the value is equals to -1, do this. I have seen a code too, that gets line. They will not call it I don't know. What I understand by a function is that when you want to use the function, you have to call it, right?
Okay.
But now you are just comparing it. Does it mean that it will? I don't think. Can you understand what I'm trying to say?
Yeah, I get you.
I don't know how to construct the question.
So from the beginning, getLine, for example, we know that
Okay.
getLine accepts 3 parameters, right? And getLine, once it's done executing, it will return the number of characters in our buffer.
Okay.
All right. Just
Yes.
like the printf function that we implemented almost about some weeks ago, right? The instruction says that your printf should actually return the number of characters that it's printed. So getLine to whatever number of character that it will actually accept from the user, it will also return those number or that number back, right? So we are actually initializing or possibly assigning that number which getLine is returning to our variable n chars. That's number of characters. All right. And we are raising a condition here to see if in case if it is the end of file value, then that means that we want to close from our program. Actually, when it returns -1, that means that the user himself have inputted a particular command that he wants to close the program. So that's the reason, and the only reason getLine will return -1 in case if there is something wrong or possibly the user manually wants to exit from the program. All right. Now, if we scroll down to execv, actually execv is a command, yes, as you said. But once we call the command, or possibly the function, sorry, once we call execv function, it executes on its own. All right. And just the same way as getLine returns something, execv2 will also return something. And we want to actually compare and see if what execv is returning is -1. And see, execv actually accepts 3 parameters. All right. And we got to know that execv says that, or possibly the man page says that these 2 parameters should be nullable. That means that they should be null terminated, right? And this should be the let me see, the environment variable, or possibly the name of how should I even put it? This should be the name of our environment, or possibly our path, where we want execv to locate that program from. So if execv does not find that entity out there, it will return -1. And if it is equal to -1, they are saying that just print command does not exist. Otherwise, we want execv to just execute. Then we'll look back to our prompt. Then our program will just print the prompt on the screen again, waiting for the user to input another command. I hope you get it.
Yes, I'm getting you, but something that is not yet clear to me is that, like, unlike getLine, you actually assign getLine to, like, you have called that getLine first before comparing it. But for this execv, where did we call it before comparing it?
Yeah, so you can actually, okay, maybe, yeah, comparing it in there is what is actually, because we can actually decide that let's just call our execv outside the condition. All right, then we assign whatever that is returning to a particular variable. Then after that, we just compare the 2 together. It's just that we are doing 2 things at the same time. All right, inside our conditional statements. They say that execv will execute, then whatever that it will return, we'll compare and see if it is -1, then we just want to go on and do whatever that we need to do. So it's just doing two things at the same time. execv will execute, then we'll check the condition to see if what execv is returning is -1. All right. So let's try and just create another variable. All right. And let's just say exc. Yeah. So in Windows, we have exe there. Okay. So for you to just get it, oh, I forgot to add my semicolon. Right. Then we'll raise a condition and we'll say if exe is actually what? -1. All right. Then our function will just execute. But we haven't declared exe. Okay. Yeah. So we just have to make sure we check it out. So where is an int? Make sure that execv will return an integer data type. Let me use a man page. Okay,
It
yeah.
has no return value. It has no return value.
Yeah, but
it overrides. It overrides.
Yes. Let's see. This is huge. So I want to see where execv has its return status so that we'll all just see it from here. Yeah, so on success, so once it is successful, execv does not return anything. All right, but on error, it returns -1. That means that if it didn't find a command, it will return -1. Please, I believe you get it. Yeah.
Yes.
So if we go back to our program, now execv is being executed. Whatever that it returns, if it doesn't return anything, voila, we are good to go. All right. If it also returns something, it will just assign that to this. Then we just check and see if it is equal to -1. We just say command does not exist. So let's just save our file, recompile it, and if we run our code in/ls, it's still working. So you see that there is no difference between the two, stating execv inside the conditional statement and also outside. The advantage is that it just reduces our lines of code.
Okay.
Right? Yeah.
Thank you. Thank you very much. I also have another question. Why are we freeing the buffer?
Yes, because getLine automatically actually allocates a space for buffer. The same way that it's able to calculate, or possibly it uses the buffer size, right, to actually do that. And you see that we don't have any let me say any hand in dealing with our buffer size, because actually I used VS Code earlier and I checked it, and you can see that anytime that you run the program, when it gets to getLine, buffer size is already being initialized or possibly being assigned a particular size, of which I didn't input that. All right. Yeah, and buffer will also definitely contain something, and getLine will return the number of characters, and buffer, it's being allocated a space dynamically. So if that is so, then at the end, we have to make sure that we free our buffer, because one recommendation or one one of the recommendation is that we have to make sure that we manage all memory. Let me say we make sure that our code doesn't incur what memory leaks. So
Okay.
that is just for us to put ourselves at a safer side, and also to prevent our program from crashing. All right. Okay.
Okay.
So
Thank you
so
very much.
yeah, you're welcome. You're welcome. And all right, set. Hey, wait, set. Are you here?
Mr. Emmanuel,
Yeah. Hello.
please, can you shed more light on the static?
Please come over again. You said I should share more light on. Yes.
It's static. It's static. Please, can you shed more light on that?
This.
Yes,
This.
it's static. Yes.
Wow. Actually, there is no much explanation to give to really qualify this particular function. So for it to make it simpler, let's just go to the man page. All right. And we will all just read through it together. Because
I have a reason why. I have a reason why I asked you to do this. Now let me tell you. Please, I would like you to do something for us all here, because we are about 30 something here. And this knowledge will be very helpful. Please, can you briefly teach us how to understand and utilize the man page? Because to be honest with you, it's one thing to read the man page, and it's another different thing to understand how to use the man page. Now, in the real world, they actually teach people or fresh developers how to use, they call it documentation. But in C, I got to find out it's called mapping. So this is virtually documentation for C. Please teach us how to use this. Thank you very much.
Okay. So all right. So I believe you all know how how to actually start the man page. Okay. So there are things that you just need to know about the man page. So first of all, we have the description, we have the name, we have the library. So the name is actually the name of the function itself. So you see that it has a short summary about what the file or possibly that particular function does. So we have the name of our function, which is atty, or whether it's sati. Then a short summary about its function. So it says it tests whether a file descriptor refers to a terminal. All right. So that's giving us a short description about what the function does. Now, the next thing is what? The library that it belongs to. Okay, so you see that it's saying it's a standard, it belongs to the standard C library. Okay, and there's the synopsis for the library, like in which header file does it belong to. You can see that it belongs to what? To the unit std.h. All right, cool. Now this is the syntax, or possibly this is the prototype for how to use what is SATI. And you could see that this is it returns an integer data type. There's the name of the function, and it actually accepts an integer. Right? It actually accepts an integer. So the next thing too is the description. So most of the functions, you have a very huge or possibly a very vast description about the function. But in our case, a SATI is just having few, right? And it says a SATI function tests whether FD is an open file descriptor referring to a terminal. You see that it has really expanded it a little bit for you to really understand what it does. Now, the next thing that you also need to pay attention to is what it returns. All right, what is its return value? We know that actually it returns an integer data type, but what actually does it return? Does it return just a number, or does it return any error code or whatever? We just need to know. Okay, so it says it returns 1 if FD is an open file descriptor referring to a terminal. So that means that if whatever that we are passing to is SATI, if let me say, just like in our case, we are using the shell, for example. If our shell is in interactive mode, all right, then a SATI is actually going to return 1, which means that it is true. All right, that means that our if condition is going to be true. Okay, then we'll just print our prompt on the screen. But if it is not, it is actually going to return 0. You see, otherwise 0 is returned. That means that it's false. So we are going to skip our if condition. Then, and error is set to indicate the error. Okay, so for this, I cannot really tell much about that. I don't know whether this too is also being passed to a setting or whatever, but I don't know. Okay, so you just have to check the return value. You have to check the description, the synopsis, a library, because there are certain functions, they belong to the system library, like the system environment. All right. I think we have something, is it CMD line? I don't know. Okay, I've forgotten about that particular command, but we have a system function like that, or a system program like that. So you just have to check the library. You have to synopsis, which file it belongs to. How do you use that particular function? Okay, and you read the description. What is it? You return it. Okay, so for here, we got to know that if it is successful, it will return 1. If it is unsuccessful, it will return 0. Okay, all right. That's all. If you want to actually read further about this, you can add the attributes, and you can also add all these ones, which is error, yeah, and others. Okay. So I believe, Mr. Chuku, I believe I've explained it's fine.
Yes. Yes.
I was faster. I was speaking faster. I believe it's cool.
Yes, it's cool. It is cool. Not just for only me. If another person has a question here, because on how to understand the mapping, it should actually
yeah.
The mapping. Because if you really observe what Mr. Emmanuel has been doing here, he has been referring to the man page at intervals. He will code and he will come to the man page. Okay. And the question is, why does he always come to the man page? That's because you cannot really have everything in your head. And that's why the man page is there for you. So knowing how to use the man page is, it's a very handy tool to understand how to do it. That's why I did that. So thank you very much for explaining.
Hello.
Yeah, hello.
Yeah, I am Nathan. So I have a question. Just I understood all the concepts that you taught us today. I really appreciate that. But the way you did it, is it's different for me. And would you please review all the code once, if you don't mind? Just especially the thing that I want you to make it clear is about how to use a token. Like, I know the token is for delimiters. It uses the input use, like the the input when a person just inputs a command with quotations, space, and then it skips those extra commands and just picks only the true commands only. So I understand that, but the way you did is little bit just it's good. It's appreciable. But just I want you to just review it once, please.
Okay. So, yeah. First of all, we have a header file, all right? I mean, all the libraries that you need to include along our coding, we were adding them up based on the functions that we need to implement in our code. All right. Now, let's go back to main.c file. We implemented some manual functions, and we know that per the requirement, you're supposed to actually use the right function. Okay. And I think we can also use the p error function to print that's to print errors. Okay. Yeah. On the screen or possibly on the standard outputs. So we just implemented a function that can also actually print a string for us. All right. Okay. Now, once we are done, we now looked or possibly jump to our main source code, which is our main function. Now, our main function is actually accepting, it's actually, yeah. So our main function, we just pass these particular parameters, all right? Not that it's actually going to accept these two parameters in the environment, but just to cut off these lines of code and everything. So we are just passing this to it. And we just want to put ourselves in a safer side. So we just typecasted C because along the line, we are not utilizing C anywhere, right? Now we initialized or possibly created our variable or possibly our pointer prompt.
Please, Mr. Emmanuel, please, I have a question. Was it necessary to typecast it to void? If you don't do it, is the program not still going to run?
Okay, so if we were to be using those options or possibly those error checkers, which is W W extra, and all the others, we will actually get a compilation error because they will tell us that we actually declared this, but we didn't use it. All right. Yeah. So to just prevent this, if you typecast it, it's cool. You will not get any compilation error for that. Yeah.
Okay. Does it mean you could have also done something like attribute or use something like that?
Please, you say, come over again. I didn't get you.
All right, I was asking if it's also okay if you can use something like underscore attribute underscore then in bracket review and use. I think the concept was taught some weeks back.
Okay, well, I'm still struggling to hear you. There's somebody here.
What he's talking about, talking about, I totally understand it. I mean, why you can use that, but this is also a shorter and another way to use it. Now, he's talking about the underscore unused underscore attribute. That's
okay. Yeah, I get that. Oh, okay. Yeah.
Okay.
Yeah, I can prefer to use that one too. Yeah. Okay. So we just created our prompts, all right, and it's actually a character pointer, and we just assigned a string to it. And we created another pointer, which will actually be a buffer, which will be storing our input from the user. And we also have our argument, which is actually a pointer to an array, okay? And we also have a delimiter. So we'll use it for the string token. That's the string talk function to actually split our string or possibly whatever that the user will input into separate tokens. All right, separate tokens. Now, we have our okay
concerning the ARG pointer, that ARG array.
Yeah.
Is it the same thing as that argument vector? I still have I don't still understand. Like,
Yes. Okay. So one thing is, it is just a variable. Okay.
all right.
Okay. So all right. So
Yeah, please answer that one first, please.
all right, no problem. So
Thank you.
so actually, is it that it's actually a variable. So I can decide to just change the name to car, all right? I can just decide to change the name to any other variable that I prefer. All right. And you can see that all that I need to do is just change its name in where I was using them. So it doesn't really matter however that you name it. Right? Yeah.
Thank you.
Okay. You're welcome. So now you guys want us to go deep into the strict implementation. Man, okay. Okay, so now we have this side. We are actually calculating for the buffer. Okay. And yeah, all right. Now for this, we use string token. Yeah. So actually, mostly, okay, I've done that before, but I don't know of the other aspects. But I actually got an error when I didn't include int C. All right. I got an error for that. So just to put me at a safer side, I just decided that let me just add int C to prevent me from it. Because actually, I think one error that I got was that I'm actually deciding to use an argument vector, and they are telling me that I didn't include the count. All right, the parameter that will actually what counts or possibly store the number of arguments that the user passed. Yeah, so just to prevent me from that, I just added this to it. All right. Okay. All right. So Mr. Sets. Okay, so let's we have how many lines of code? We have 80. Okay. Now we just want to make our code a little bit simpler. So these functions, all right, we'll just try and cast them into another file. Okay. And we can decide that even with this, our print string, okay, this is just one single prompt. Okay, it's cool. We won't get any problem with that. And get line 2, we won't also get any problem with that. It's cool. So we can decide that these functions, we want to cast them into what? Into a separate file. But let's just still box on. Let's still move on. Now we check and see if our buffer, our number of characters is actually returning -1. They will say that let's just exit from there. Okay. Now, while buffer with the index I, okay, if buffer I is equal to the null terminator, we want to do this I++, all right. Then Okay, we raise this, we call our string token. Okay, so I think the next implementation that I want to inculcate is where we will actually be checking, like we'll actually be running to our path to read or possibly locate our code from there. This is our fork to call the child process. All right. This is also our string token. We tokenize it with each one. All right. So let me just try and create another program. All right. All right. So I'll just create another function, another file. All right. So that we'll just implement how to get our path from there. So there is one particular function. Mr. Pascal. Hello. Okay, I think Mr. Pascal is out. Yeah, so I want to actually implement how we can get our path from the system. Remember that in our shell, our local shell, this one, if you just type this $ plus path in caps, this is my entire path. And you see that it's being separated with what? With a column, all right? It's being separated with a column. So all these are the directories where my executable programs are being stored at. So if I type ls in my shell right now, execv automatically, all right, this will be the parameter or the argument that I'm passing to my shell. And this is actually going to be argv0 in our case, all right? And execv is actually going to take this and is going to search through all these entire directories to see if it can find ls out there. So if I hit enter, it does that within a split second, and it retrieves the ls command to print out this content for us. Now imagine if man is not found in any of these directories. It will just say bash, the command that I inputted, command not found. Right? Yeah. So to prevent us from typing bin /ls for it to execute it for us, we have to inculcate the path, which is PATH, into our program, so that when we type ls, it will work without any errors, or possibly without without us calling our function in a long format. Okay, so let's go back to vi gets lock, right? And since you are going to return the path, and the path is actually a string, okay, so let's just say our gets function or our get lock function is going to return let me say yeah, it's going to return that string. So get lock is actually going to be a character pointer. Right? No, let me see. And it will accept a command that we inputted. So arg, right? Then let's create another variable which will store the path for us. So we just name it path. And there is another function. Let's go to the man page and let's see if that function exists. So we call it get env. Use it to get the environment variables, right? So you see get env, and we use it to get an environment variable, and it's being found in stdlib.h. And this is the prototype for using get env. It returns a character pointer, all right? All right, or possibly it's actually a character pointer. All right, so it will definitely return a string. And this is also a character pointer, right? So it's actually the name that it will take. What variable that do you want it to search or possibly return for you? So if you just input path, it will give you all the content in path for us. Okay, so let's scroll down. SC return. It says get env function returns a pointer to the value in the environment or null if there is no match. So you see that if there is no match, it will return null. But if there is a match, it will actually return that value where the pointer is pointing to. Okay, so let's go back to our get lock function. We'll call path, then we'll call our function get env. Then what is the name of our variable? We just call it path, right? Yeah. Return the content of path to this, that entire string, it will assign it to path, this particular variable. And after that, let's raise a condition and let's see if it worked. Man, seriously, Mr. Pascal, let me read what you sent. Wow, seriously. Okay, so yeah. So before I move on further again, let me see. Okay, so if I raise a condition, there are more things to implement out here. Okay. All right. So I'll just raise my condition and I'll just say if path do exist, then let me say path is equal to. But there is one particular thing that I also need to implement. All right. Because when path returns opposite, when if get env returns our path back, this is actually going to be the entire string. For example, when we printed path, right? Yeah. You see that this is a vast string altogether. And see, we actually just want one directory after the other. Okay. And we want to actually read through every single directory based on the command that the user passed, so that we'll see whether we'll be able to find that particular command out there. So that means that we are not going to stop there just by using or calling get env to give us the content of path. but we have to make sure that we split this entire string into separate tokens again. All right. Yes. So that's what we are going to actually deal with right now. So we'll get to get lock again. And okay, so this implementation will be a little bit tough or possibly a little bit long. Let me try and implement another function. All right. I'll try and cast it out once I'm done. So I'll name this one location. Okay. Yeah. So this will give us those individual directories. Okay. Those individual directories. Then we'll just deal with them based on the command that the user will pass. So car location. So I will let it accept the path. Then the command that the user will pass here, lock will actually accept it. Then it will search for that particular command in what? In our path. Okay. So location actually accepts our path, all right, as a character pointer. Then our arg as a character pointer too. Once you're done, we want to okay, so there's actually a pointer. That means that any changes that we will make to path will will actually reflect in this string itself. So that means that we need to create a duplicate. All right. And we have a function that can actually help us, which is str.dop, or possibly you can use string copy any way that you prefer. Mr. Pascal, I don't really know, but I think it has skipped me a little bit. All right. But I don't know whether okay, let me try and see, to be precise, whether okay. Please give me a minute. I'm coming. Sorry about that. Okay, so I want to yeah. The the access. Okay, let me use the man and let me see. Let's try access and let's see. Okay. Okay, so I said, okay, so access actually takes in the path and the mode. Now, what is the mode? Let's go down. So the mode specifies the accessibility checks to be performed, all right? And it's either the value, which is FOK, or a mask consistent of the bitwise or of one of the main. Okay, so check is done using the calling process real UID rather than the effectiveness ID and all that. Okay, right. On field, the things you can do. Right. Okay. All right. So instead of get env, we can prefer to use access, right? Yeah, we can use access. Okay. Da, da, da. Okay. So, but I think access, hold on. Access actually accepts two parameters, which is the path and the mode. Even the should the mode be? Okay. So he said it's a bitwise operator. Yeah, it's okay. Sure. Okay. Mr. Pascal, I believe I've done this right.
The path, that path, I think what you should pass is the, in a way you're doing those slash bin slash, I think that's what you should pass there. I don't know. I can't remember though, but I don't know, but that's the way to use it though. So it returns something. So if it's okay, like if it passes it, that's it will return 0. So yeah, but this first parameter, I can't remember how it's used unless I have to check it. It's been long, I can't remember. The first parameter was.
This is something. Okay. Please give me a minute, please. I'm coming. Please give me a minute. Come on. Yeah.
No, the answer is, I think what it does is it checks the, when in the bin folder, that's where you have all the executables, all those slash bin slash echo slash bin slash all those is it non-built-in or something like that. That's where you find those files. So it checks to see if it's there and if it has the permission XOK, this is executable permission. So if it's correct, it returns 0. That's what it does. So that's the access. That's the handle parts section in the tags.
Okay.
So we use the access to check if the part exists. So that's it.
That means that I still need to go back to my get env.
Somebody
Actually, there is a way that you can actually also implement your own get env function. All right.
Sure.
All these things are a long process. That's why I'm actually using the inbuilt own, so that it will skip me the stress. All right. Yeah, even the get location function that I'm even trying to implement, it's giving me a headache. Okay, so let's go back to how I get work function. So yeah. So instead of that, we can just actually raise the condition. Okay. Yeah.
Sorry, Emmanuel. You know, some users can be very funny. They can just go and put /bin/Pascal, which it doesn't exist. So what this access does, if I remember how we used it then, was it checks to see if what the person entered, if it's actually accessible and if it exists and is executable. Before it, you can proceed to the exec VE to continue the execution.
Yeah.
So that's it.
Okay. So then, is it possible that we can assign access to path inside our conditional statement? Because I want to actually use that so that it will, I just skip trying to reinitialize it to path again. Yeah.
But this access returns a value, you know, it returns 0.
Yeah.
So you have to equate it to 0. Okay, yeah, it will work. Yeah, it will work because, but if you say if, okay.
Okay. Anyways, let me just skip that. Let me just use the manual way. So that's
exactly, because if you use it like this, if it will return 0 and it will not execute. That's if 0, so it won't work.
Yeah. Okay. So did you say it returns 0? Did you say that?
Yes. Access returns 0. This access, if it finds that the path is valid and it has an executable permission on that particular place it's trying to access, that's the file, it returns 0, which is success. Okay, yes.
I'll have to. Then okay, so we're trying to implement our get location function.
And what if access fails? What will it return? And what if access fails? And what will it return?
I think it's negative. Yeah. It returns a negative.
It's negative, right? Yeah, it's negative.
Okay.
Okay.
I'm thinking you should check the man page for the first parameter, this part that you wrote, what is supposed to be passed. Yeah, I think it's a valid
access
location. This part, the way you put the part.
All right.
And yeah, it's a valid location you need to put there.
Okay, so path name. It's whether the following process can access the file path name. Okay. So name is what? If path name is a symbolic link, it is dereferenced. All right. Okay. Oh. Okay. So that means that even if we have to call the access, we have to still make sure that we tokenize our entire path before we can actually call access. So I don't think access will be we'll be looking through the entire path per se, but it will need a specific file to just look through them. Right? Because
I get you,
after we return the entire string to path, which is our variable, you see that it contains the entire path as a string. Okay.
That's true.
And access cannot look through that entire string because we've not tokenized it. Yeah. So I think
that's correct.
That's okay. So let's try and do that.
sorry if I may ask, do you really need all the whole path, like all the parts?
Okay,
In the
okay.
yeah.
So actually, we've dealt with that's passing the manual path, which is /bin/ls, and it's working all right for us. But I want to implement where we don't need to input the manual, let me say the absolute path before our function will work. We just want to input only the function, the command, and it should be executed for us, right? But in our
Okay, I get your point. I get your point.
Yeah, it's actually not working. So that's
I
the
get
reason
your
that we
point.
want to get access to the path. Yeah.
Okay, I get.
You see that when we call ls, it really works. And even if we pass in a parameter, an option to our ls hyphen a is still working.
I get.
The command alone does not work.
I get. Or the way some people did it in our time then was they had to create an array and kind of do a concatenation of this to the /bin/.
Yeah.
That was what they did anyway. So that's one way anyway. So
okay.
Yeah, sure.
Okay, so we move back to our get log file. And yeah. Oh. Hey, 10. And so okay. So we just accept two parameters, path and the argument, which is the command that the user will pass. All right. So okay. So let me try and create another argument. That's another variable, right? Which we use it to duplicate this path because, as I already said, it's a pointer to actually accept what our path, and we don't want to actually try and make some changes in the original string. Okay, so we just want to duplicate it up so that we can actually work with the duplicate. Okay, so another character pointer. Let's just name it path underscore and maybe add CPY for copy. Then we'll utilize strdup, which is string down with path. Okay, so we just call path underscore CPY is equal to string down. And we'll pass in our path pointer. No, the next thing too, I think we need to, yeah, we need to also tokenize it. And as we did with when we accepted a string from the user, how we tokenized it, we'll also try and implement the same thing also here. So let's just try and say, let's say P. I don't know whether this accepted in C. I don't know. But man, who is that? Okay, so we can path then token, right? Token, right? and our path copy. And we haven't included a delimiter. Remember, that when we checked our path, or possibly the strings in our path, or possibly the directories in our path, we could see that they are being separated with what? With a column. So that means that our delimiter or our separator is going to be what? A column. So I'm just going to put in here column, right? I'll just put them as that. Then, as we read from the man page, the first string talk will actually, we should actually pass the what? The buffer itself. So in our case, path copy. Then the subsequent ones, we have to what? We have to actually utilize what? We have to actually which one? Yeah, we have to actually utilize the null, yeah, the null to actually delimit all the others. All right. But there is something else too that we can also decide to use. All right. There is something that we can also decide to use. Now, so let me raise my condition. So while let's say while the path token it's not equal to null, yeah. And then null. Okay. Okay. So now there is something. Every single path actually ends with what? With a forward slash, or possibly every single path should end with what? With our forward slash. Then the name of our command should follow. That's the reason that we are actually passing @v out here. So I'll be able to use it in there. So then the name of our command should follow. Then the last thing should be what? The null terminator. Okay? Yeah. So we just want to see if that particular command exists in that particular path. So that's the reason that we actually just going to do all these things in there. It's not going to be anything hectic. All right. Now, let me try and reinitialize or redeclare another variable again. Now say file path, right? Which will be the path of our file, right? Okay. And I'll just say while path token is equal to null, then I'll say, okay, are we supposed to use string copy? Let me see.
I think it's not equal to null.
Okay, we are supposed to use string top. Okay, we're supposed to use stats. Man, please. Yeah, string copy is not parts. Please, I beg you. Let me. Okay. We can actually decide to implement. Yeah. Yeah, we can actually, along the line, we can actually also decide to implement our own string copy. But let's just still use C's own. Okay. Yeah. Chairman. Because So we have our file path at the top there. All right. And we have our token. Okay. So I think that's it. Let's just say, so we just call our string copy. And we know that for string copy, there should be a destination and there should also be a source. So we will call our file path, right? And the source is actually going to be our path token. And we know that when the token, if string talk actually tokenize our string, it just splits them one after the other, all right, using the delimiter. And that's what we're actually doing, right? So we just say file path, then our path to token. Then we'll call string cat. We use it for what? For concatenation. That's we use it to add strings to each other, or possibly add two strings together. Yeah. So I believe for all these functions that I'm trying to highlight, we've already implemented all of them earlier. Manually, we've implemented string copy before, string cuts. We've implemented all that before. So simple shell is telling you that prove yourself that you've really you've really worked at what and strived on C. So string cuts, let's just use that. So file path 2. And this part we use our /. Why? Because after every single directory, even when you use the mv command, if you want to move a file to a directory, you have to make sure that your directory, you end it with a /. All right. Else mv, which is the move command, will actually think that you want to actually rename that particular file, which is not so. So our path name, or possibly our path, we want to actually concat it with what? With a /. All right. Then after that, the name of our command will also follow. All right. So that's what we actually doing. Then we'll call string cuts again and file path. Right. Then our command in our case, which is what? Arg. All right. So then the last thing, we have to make sure that we end with our null terminator. Hey, if I'm doing everything right, I'm getting okay. Yeah. Yeah.
I'm thinking this is supposed to be not equal to here.
Yes, it's not equal to. Yes. Not equal to.
Okay. Then I think you need to also this guy, this part. You need to malloc, maybe.
Sure. Thank you.
Yeah.
So okay. All right, so let me just let me add another thing too. Since I'm mallocing, okay, so size of arg, then because there's actually a pointer, okay, size of arg, then We'll also accept the length. Okay. Okay. All right. So let's just say path token, that's additional 2. Then I want to implement something else too. We have our path token, and we actually also accepting a command from the user. And the command, we don't know what it's actually going to contain, like the entire thing. Okay, so let me just try and use the string length to also, yeah. And leave, it will be fine. So the reason I'm adding 2 is actually because of these extra additional characters, right? Which is the / and the null terminator. So I'm adding an extra byte to the size of our file path. Okay, yeah. Right. So I believe we are good with the location. And we are supposed to actually return something at the end. Yeah, we're supposed to return a path. Okay. So.
You didn't free. There's no free.
Yeah, no, I'm not done implementing location. Yeah, I'm just trying to read through. Is there something else that we need to do?
I'm looking at the return. You didn't return. There's no return value.
For yes, I'll return something. Yeah. But I want to actually implement all these. What we will return is actually going to be either the command or I think, yeah, we'll actually return the command itself. All right, that it was being found in a path. So including everything. Yeah. Okay, so just to put us in a safer side, let me first of all add our free, then our path. Our path and tokenize path token. Right. So that's we actually malloc. Now, the next thing that we want to implement. Now, the final content in our file is going to actually be the entire it's actually going to be the entire let me say the entire path to that particular command. And we want to find a way where we can actually read through each and every single. Okay, so we still haven't implemented the tokenization. Yeah, we still haven't implemented the tokenization. We just took the file path and we just concatenated these things to it after each other. All right, and this is actually the first token. All right, the first token, that's what we're actually dealing with. Yeah, that's what we're actually dealing with. But what about the rest too? Yes, the rest is what we actually have to think of. Okay, so let me raise a condition that we'll actually use it to tokenize the rest that is left. Okay. So I'll just say if into brackets or file path. So in case if it is valid and nothing or anything didn't go wrong, then we can just say, oh, semicolon. I just say path in or path token. It's actually equal to strt. Okay. And we add our law and our delimiter. Okay. Yeah, so we have our delimiter here. Okay. Yeah, so even before this, we can actually even implement the stats also here. But let's go to stats so that we'll all read through the man page together. Right. Okay. So we actually use that word to display the file or file system status. So display file or file system status, mandatory arguments to long options are mandatory for short options too. Okay. So we could see that this okay, so if you are okay, don't worry. In Linux shell, we can actually use the long form of our options. That's the short form of our options. We can also choose to use the long form of our options. All right. So I think it starts actually uses this to check this particular status of file of our program. Okay. And has it returned anything? I can see. Okay. All right, let's see how stats also work. So stats will take in an option and the file itself. To take in an option and the file itself. Da, da, da. Man. Yeah. That is it, and you are good to go. All right. So VI gets location and Okay. So we use our delimiter. And as it, I think, if path, if it is valid, we just tokenize our string top. Is there any further thing that we need to do? Yeah, I think that's it. That's it. All right. So for decide to return no. If it fails, then okay. I haven't declared this yet. I just say structs. No, hold on. I think I'm trying to confuse myself out here. Hold on. Because for stats, yeah. Why did I even say that I was going to use stats for?
I think the start returns, it checks the file if it exists, it checks the status of the file.
Okay.
And returns zero if it's successful.
Yeah. All right. Okay. Cool. So it will definitely return a 0 if it is successful. All right. And my VI is in visual mode. Oh, what is the buffer that I want to? So this one too is a file. Okay, so let me just stick the MDB. Where's that starts? A. And in case if it is equal to 0, right? Then we would like to okay, we would like to return our command as if we didn't find it out there. Um, okay. I believe that's it. Wow. I need to go back and read more about. Okay, we are still not done with the get lock. Sorry, forgot that I'm actually using two functions in here. Okay. Actually, with that, just passing the command back to what? To our path. All right. And the name of our function is lock. Takes in the path, the parameter, and it also takes in an arc. Yeah, I've been saying command, meanwhile it is arg in here. Right. And then this is actually a function that we are going to call in our main function. So it's going to return our path to. In case it fails, we just want to return now. Right. Let's go back. Save our file. Our main.c. Back to our main.c program. So we are getting the location. Okay. So, it's getting too much overwhelming. I could have decided to split my functions earlier as soon as possible. Okay. So, up to 16. So we have 13. Just let me try and implement my functions in here. All right. And then these are all the functions that we've implemented. It's patient. Yeah. 20, 50 minutes. Right. Hey, cool. Let's go to our main.c file. And let's decide to implement our program before our exec v and everything. Okay. Right. So this is our tokenization. We use it to actually split it into two. Now, where do we call our getLog function? Okay, so add v. Okay. So we are implementing. All right. So initializing two match variables are here. So I just say pass, because you are returning path from getLog. That is, we just call in path also. That's get underscore, right? Then we pass in our arg man. Make sure. Okay. So I think that's it. Okay. Now, once we've done that, we are no more going to pass in at v with the index 0, or rather, we are going to pass path to our exec v. All right. Yes. And this is the entire array, and this env. Okay. Okay. Let's see. Hey, we are getting 1,000 errors for that. Okay, let me try and cross check it. Okay, I forgot to add my semicolon for this. And it's supposed to be location or path inside our getLog function. Yeah. Okay, so location. Location. And I forgot to add a semicolon for return path. No, it's not this one.
I think it's on your main.c file. Okay.
Yeah, the main.c. Thank you. Yeah. Sure. All right. Oh, okay. Okay. Yeah, it's because I'm using stats. You're asking me that, hey, do you mean you want to use str cat? Let me check the man page to confirm. Because okay, it's actually f stats. And we also have stats as a command itself. Okay. So let's go back. We have man2 stats. All right. Okay. So we also stats actually accepted the path name and the stats buffer. All right. So function returns information about a file in the buffer pointed to by stats_buff. No permissions are required on the file itself, built in the case of stats, or whatever. Permission is required on all of the directories in the path, and that leads to the file. Okay. You can even if path name is out. All right. So it actually works the same way as the access. Yeah. Works just as the access. Oh. Because that actually returns ints. You're checking it to see. Then let me try and comment this out before any other thing. Let's see. Just to prevent us from errors. Okay. Let's save our code and so implicit declaration of write function. Yeah, so the print.c file, I haven't included our main.h. So please, let's go there and add in our header file. Okay. Expected identifier token line 3 main.c. All right, to fix that. Then our path is equal to gets log. It's actually a double pointer. Like I'm actually passing it as a double pointer. Okay. So all these are in our main.c. Here is actually a single pointer. Yeah, but we are passing this as a double pointer. Okay. So line 3. Okay. So there is a trailing curly brace here. And the other one to path. Let me see arg how. Okay, so add is actually a pointer. All right. Let me decide and take this out. Okay. Yeah, these people are just trying to make my day very worse for me. Okay, so let's go back to our main.c file. Anyways, let's make sure that we make it a pointer to an array. Right? And if that is the case, getLog actually accepts they're saying that we are actually passing it in such a way that, all right, getLog is supposed to accept, it's actually accepting a pointer instead of receiving the address itself. Okay. Is it, Mr. Pascal, is it possible that we can just pass the pointer straight to it? No. No. Let's do it this way. Let's see. Okay, size missing. Man, I forgot to add that. All right, so first of all, I place in 10. All right, GCC. Okay. All right, let's see. Okay. Does not exist. Still not working for us. Okay, that means that there is something that we've done wrong in our code. It's something that we've done wrong in our code. What could be the possible reason? What could be the possible reason? Be the possible reason. Mr. Pascal, are you here? Hello. Oh, I think Mr. Pascal has run leave me. Okay, so if we go back to a code, simple error. Hmm. Hmm. Okay. Yeah, so let's try and use the access here. So we want to check if the file path actually exists. Right, yeah. Um, right. Then just want to say path, string talk, and all that. But there's something else that we need to do. Okay, yeah. So then if that is so, then what we just want to free our path copy because we initialized, yeah. So string dump will actually automatically initialize file path copy. So let's try and release that. And that's called CPY. Then we will return our file path. Right. That's only when it do exists. Then we just want to return that particular path. Else, we just want to go on and tokenize our path with a token. And this last one, so let's try and free file, I think path copy. I think we're good to go for that. Okay, now let's try and see the get log to if there's something that we are not doing right. Okay, we are calling the path. Okay, okay, okay. So instead of calling it here, I've already declared it out there. I've already implemented it out there. We just call the file path get env. Assign a path to it. Then after that, we just cross check. We just call the get location path. Then we return the path. Whatever that we get, we just return it. Then we say no. Right. No. Okay. So let's go back to our main. Let me see. Main. Comment, we have our shell. We have our buffer. No. We have our delimiter. Okay. Which is a character pointer. We did that. As SSI, so we initialize the buffer to 0. We have this one to the number of characters that gets line also return. Our PID for our child process. Our status are I, J, and EXE. Now for this, we'll start our while loop. We'll check and see if our program is being executed or possibly if it is in interactive mode. We just want to print our prompt If else, anyway, we just want to print or possibly get an input from the user, then we'll check and see if whatever that the user gave, if get line returns -1, we want to free our buffer, then we want to exit. Okay. Now we actually look through our buffer and we check and see. Okay, so we definitely just want to assign the last character or possibly the null terminator of our buffer to 0. So we want it to be null instead of the new line character. Okay. Then this is our tokenization. We just tokenize our string, our J, and all that. We just increment it. We tokenize it throughout. And okay. And I forgot to, I already said it, but I think I forgot to add it. Said it will always return a null. But for us to be sure, let's, okay, if that is so, let me put 11 here. All right. Yeah, just for this extra null terminator. It doesn't matter, that's who gets. Okay. After I will call our getLock function. Then okay. All right. So let's raise a condition and let's try and say path equal to null. So in case if getLock doesn't return anything, we just want to utilize our print string and just want to repeat whatever that we type and say command found as not exists. And since we are still in our loop, let's just try and implement continue. Right. And after that, we just come in and call our child, which is the fork. And we'll check and see if whatever that the fork function returns, if it is less than 0, we just say fork failed, we free our buffer, then we'll exit from the program. And in case if whatever that the user passed is actually equal to 0, we will just run our execv, all right? And we will check and see if execv actually returned -1, then that means that it still doesn't exist. That particular command doesn't exist. We'll just print command does not exist. Okay. All right. And that is it. I'll wait. Don't have to go for, okay. So let's recompile. Let's run it ls. Oh, wow. It's working. Cool. It's working. Now echo. Hello. See, it's working. Wonderful. So, by the grace of God, we've been able to solve this very tedious. Wow. It's cool. It's cool. So, we can use our cat command and we can actually use it to cast the content of our gets lock. That's gets and that's for lock file, and see printed it out. Wow. Now we can say ls-la and working fine. Okay, so basically, I think, okay, so we can actually decide to implement some built-in functions too, okay? And the built-in function, we can actually just check and see if whatever that a user pass is the exit command. All right. They want to actually exit from there. So you see that it's returning command not found. Okay. We didn't find it out. If I type, you say CD. No. I don't think CD is actually going to work. All right. Because CD is actually a built-in command. All right. CD is actually a built-in command that we need to implement. Yeah. So we can decide to start with that. Okay. I think malloc corrupted top size. Yeah, there was something wrong somewhere. Maybe it could be possible that I forgot to free my space. Yeah. So where could that memory leak actually go on? A file path, and I believe we freed it. Yes. Path copy, we also freed that. I believe so. Okay. All right. So, all right, no problem. I believe we'll definitely get there. And VI main. We didn't allocate any malloc here, right? Oh, let me try and free path because get law is actually okay, no problem. Let me try free. Let me add path to it as at a safer side. So let's try and implement some built-in commands. And I think once you are done, once you are done implementing those built-in commands, we are good to go. All right. Yeah. So you see that in our shell, let me try and open another bash shell. All right, another instance. This another instance of my shell. If I type exits, you see that it's exit. But let me use the sh shell. I think this is much more better. So you see that it's working just the same way as our shell is working. If I type ls-l, it's working. But if I type exits, now it's exited from that particular shell. And that's what we need to implement for our inbuilt command. All right. If you go back to sh shell and we type cd and maybe we move to the tests directory. Oh, I said texts instead of tests. So cd, then tests. All right. Now see, we moved into tests, and you can see that the files that we moved into our test folder, they are actually there. If I do pwd, see that now we are no more in shell, but we are inside test. Okay. Yeah. If I do exits, now we exited from our sh shell. Okay. All right. So we just want to implement some built-in commands, and we'll deal with, I think, the exits and maybe the cd. Yes, maybe the cd. Okay, and I think that's it, right? And maybe if we type this too, it also gives us some the environmental variables, right, that we have. So, well, we'll get there. Maybe we'll try that too, and let's see whether we'll be able to do that. But anyways, let's just begin from the basics. Now, let's just say builds in underscore CMD, right? That means that's an built-in command. Okay. And for our built-in command, definitely, I don't think we are actually going to return anything because our built-in command is not going to utilize execv. Okay, like it's actually a manual command that we are actually implementing. So it's not going to utilize execv. So that means that we are not going to return anything to the screen. Like we are not going to return anything to our main function. But what we are implementing here are just going to execute those things for us. Okay, so we should just implement the voice status that it shouldn't return anything. Or we can just say that int, all right? Then we'll just say underscore built in CPD. Built in should built in CMD and let me verify. Okay, so at J, so actually accepts at J. And once you're done, we are going to raise some conditions to check and see, because actually the built-in commands are just strings that a user will input. And we just want to confirm if they are the same as the strings that we are expecting, so that we just implement those instructions for them. So the first one is the exit, as we already tried it in our shell. So you see that we just raise the condition that if are we hold on, please let me check the concept page 2. Okay. All right, no problem. So let's say arg also. Then we want to call our print string function. So just say exiting. Exiting shell. Yeah. So this. Yeah, don't worry. I've seen that. I just thank you. Okay. So this basically as simple as it is for the if that's the exit status. All right. So in case if the user inputs exits, we just want to close or exit from our program. But before that, let me just implement our return. I will try our hands on the exits to see that it's actually working. Right. So main.h, let me include our built-in function in here. So ends underscore built in CMD. Then going to accept a character pointer arg, right? And actually, let me go to main, C, and after we've tokenized them, we'll say that, hey, get log, right? But we want to raise, okay, hold on, get the location or check the path to see if it actually exists. Okay. If path is null, they want to actually continue. Okay. So let me implement our built-in function in here. Let's see. And it's actually going to accept arg. Yeah, it's going to accept. And yeah. So I want to actually raise a condition to actually see if built-in CMD. Right. Because I don't want it to print it multiple times or possibly to execute it multiple times. If path is null, then we want to actually say command not found. If we didn't get it in a path, then we want to say command not found. But what if we can actually find it in our built-in commands? Yeah, that's the question. What if you can actually find it in our built-in command? That's the question. Yeah. So, no ways. You can just say if, and this one is actually returning 0. That means that if is actually not going to execute. Okay. But if built-in arg is not equal to 0, they want to say command not found, else continue. Okay. Maybe this could be okay. This is C. Hold on. Oh, print F. Yeah. And I'm also trying to compare a pointer and an integer. Okay. All right. And this one, I have it wrong. Now, built-in, I'm actually supposed to pass in. Okay, so it's actually supposed to get a pointer. Let me go back. What should I go first? Built-in, right? Let me accept it as a double pointer. And yeah. Okay. Add with the index 0. Should it be so? Let me use string copy. I think it's string compare rather than string copy. In this will be okay. Right. Yeah, I had it wrong again. Built in CMD underscore. Okay, in our header file. In our header file, I'm actually conflicting the types. So conflicted types of CMD have an int, a character double pointer, and here, our previous declaration, I'm actually accepting a character pointer. All right, and here built in, I'm actually all right. So let me go to main.h and let's add our okay. What else? All right. Cool. Let's type exits. Now see, it exited. Wonderful. Now is it I didn't print command not found, but let's rerun our code and let's type maybe new. Didn't. Hey. So it's actually supposed to print command not found, but it is not doing that for us. So that means that we need to change and then fix that. So if I type man, okay, manual page do you want? Okay, so text. All right. So that's malloc, that's memory leaking. We need to actually find it out. That's actually, we are not going to deal with that now. So we'll go back to our main, yeah, main.c file. And please, any question? Any question? Any question? Okay. So yeah, all right. So here we actually want to check to see if because we know that for our built-in command, it's actually going to return 0, all right, on success. I want to compare and see if it's not equal to 0. That means that if it's actually let's let's see that Do with this. Okay, let me add continue. Okay. All right. So you are still encountering that malloc corrupted top size. That means that we are still having that leaks in what's in our program, which we actually need to fix. But no matter, no, like whatever, but anyways, it's still working. We can actually do CD. Okay, we've not implemented it. We can actually do exits and it can exit from our program. Let's try and implement more built-in commands. And I think we just need to add one or two. So we'll raise an else condition. I would say I'm still using the string compare because it's the RCMP, then R, the index 0, right? Then we'll check and see if the user enters CD, the same directory. Just want to raise a condition again. And we want to check if ARJ with the index 1, if it is null, all right? That means that if the second parameter is actually null, because if you type CB, we know that in the shell, CB will take you to the home directory, okay? But if there is another parameter in addition to that, we want to move you to that particular directory. So if the user entered only CD without any additional option, we just want to change to our home directory, right? So I'll say CHEIR. So we have a particular command which is CHDR, that's change directory. And yeah, now call the get env command here again that we used earlier. And I'll pass in as our home variable, right? Else we want to actually change our directory to where the user wants us to move to. Let me take out these braces because it's just a single line. All right, it's not a block of code. Let's see. Right. Now, I added else here. So let me add else. All right. And for the else, I will just say, what should I even? Okay, let me just take this off. Even though I will not be closing my entire condition, but let's try and implement it first. Let's see if it is actually working. Okay. Let's type CD. Let me add tests. st/. Hey, command not found. Now let's see. Let's do ls. Man, did you see something? The command actually worked, but it's still giving us the output command not found. Yeah, this is a problem. The command actually worked, but it is telling us command not found. Phew, what could be the reason? Can somebody figure out this? This for us? Because if we type a cd command, it actually works. All right, if I type cd, says command not found. But if I do ls, see, it took us to our home directory, and we're able to print all these things out. If I do pwd, yeah, that's memory, whatever. It's giving us challenges. Let me pi. Yes, pi iterates code. Because here we will print a string, our command does not exist. Okay. We don't exit from here. Here we'll free the buffer, then we will exit. Okay, let's try and go there and let's see. Yeah. Even for the built-in command, we actually are not utilizing any mallocs inside it. Or is it the get lock, the get location function? Because I think maybe it could be coming. Yes. And I'm actually releasing it out here. Yeah. So I don't know why. Okay. There is no harm in trying. Let me try and comment this out. Okay, so possibly could be that it was coming from that one. Okay, so it was coming from that part. Yeah. Okay. So if I type exit now it's exited. So actually that was the one which was actually giving us the problem, because access, if it is true, we want to actually return the file path. And once you return it, we are still not freeing path underscore copy. Wow. Okay. Anyways, if you're, well, it's still cool. It's still cool. All right. So that is it.
You freed it once.
Yeah. So I'm just trying to wonder why yes, it's the cd command actually works, but it's still it gives us a command not found after it has worked. Yeah. Yeah.
Let's go back to the get log file.
Mm-hmm.
No, I'm sorry. The special file for the special functions, not this one. We are trying to look at the CD command.
Oh, okay, the built-in commands. Yeah.
Let's go to the built-in command. Let's go.
Okay.
Let's investigate it.
Yeah. Sure.
This looks good to me. Let's go to the main and see.
All right. So here,
continue.
you're calling the built-in command. Yes. Okay. Yes. That's because I'm actually trying to do okay. Hold on. Let me try and make some slight changes. Let's move back to, I mean, let's see. I think my idea is still invalid. But what I wanted to implement. Okay. So the continuum. Phew. Okay. Possibly after the point. Okay. Oh, um, yeah. Is it a, it's actually skips it, all right. I still printing command not found. Hmm.
Do exit.
Yeah. Hmm.
I thought it freed the man. I thought the manual is stopped.
Yes. So I'm just even trying to wonder why.
I thought the manual worked. Why is he back? Oh gosh.
Well, I cannot really explain that. Yeah. It works all right. Let's see. As to the home. And if I want to move to the next directory, example, corrupt the top size. Let me try and rerun it again. CD and text. Oh, hold on. Don't you think actually you see that I utilize 11 entities for our ag. So maybe that could also be the reason because it says corrupted top size. That means that it's either that it doesn't have enough space to contain those particular. Okay, let me try and increase it to maybe 100, and let's see if maybe 101. Okay, worked. Okay, it's still giving us the same error. Anyways, yeah, it's
Why
just that we.
Why do you have code 101 in that place? Why the hard code? Instead of the hard code on, yeah. Yeah. Do you follow? Do you understand?
Phew. So what could be? Yeah. So oh man, it's almost 12. Okay, so I think no matter what, we are still we've done something. All right. The only thing is just about the memory corruption. The CD command, which is actually not, which is partially working, right? And I think apart from that, it's cool. Let's see if we can actually open, yeah, let's see if we can open VI is inside it. So VI main.c. Oh, sorry. So process failed to start. No such file or directory. Yeah, segmentation faults. So command nvim. Okay. So they are just giving us all these long things. Yeah, because we've not implemented an algorithm which can actually allow us to run a separate program inside a shell. But the commands can actually execute and exit. And they are actually temporary programs, right? Yeah. So vi main.c. Okay, so you are still getting segmentation fault. Okay. So NVIM, that's VIM main.c. Okay. It opened up. All right. So opened. And we can even decide to do whatever that we can do in here. after we are done, we can exit and see our shell is down here. Our shell is down here. Let me use the clear. Okay. So the clear command, they are saying that we've not set it up to be able to clear the entire screen. So I don't know whether okay. Okay, for me, we did implemented a clear command. All right. Yeah. Yes, it's inbuilt. Like it uses the environment variable to actually clear it up. Yeah. So CLER, it is not working now. Well, if you well, so any questions so far? Any questions so far? All right. Oh, okay. So let's exit from our shell. So basically, there's the entry point for our get lock program, right? And it will accept the command, or let me say the arguments from the main function. Then after that, we will initialize, or possibly we just declare a path as a variable, which will actually host all the entire string in our path. We know that in the Linux shell, we have a particular environmental variable name as what? Path. That's with the uppercase letters, path. So get env, that's get environment. When we pass this string to it, it will search through the environmental variables for this particular name. So if it sees this variable, it will just cast, or possibly, let me say, yeah, it will cast all the contents of that particular variable and paste it inside this. All right, so it's just doing an assignment. So all those strings in path, it will just assign it to path. All right. Then after that, we just raise our condition to see if get env didn't work, then we just want to return null. All right. So if path do really exist, that means that if path did get something from get environment, then we want to call our get location function. All right. So from our get location function, it accepts two arguments, which is our path and our arguments. So the path is actually this path. All right. We'll pass it to our location. Then after that, the argument that we passed through to get log, we also pass it to our location. Then inside our location function, we also initialize these things. The reason we are actually creating a copy of our path is because we don't want to mess with the original string that we got from get env, because you know that we are dealing with pointers, and pointers, if you indirectly manipulate the direct value, is actually going to change in its location out there. That means that even if you want to go back and retrieve the content of that, it's being manipulated. It's like it's changed. So it's not really the same. So you just want to create a copy of it. So that's why we actually have a path copy, and we also have path token, right? We are going to use this to tokenize our path. That's to split our path into those individual directories. Then after that, we will return the file path. That's the path where the program exists. We want to return that path and the program, that's the entire program itself. All right, so we are just initializing this pointer to. Now we are going to use this particular delimiter to separate our path, or possibly to actually identify those individual paths, or let me say directories in what? In our path environments. And we use string dump to actually copy path to our what? Our path copy. Then we will tokenize our path copy using our delimiter, which is the column. Then it will assign the first token to what? To path token. All right. So the first path, it will just assign it to this. Okay. Now, once you are done, we want to actually dynamically allocate a memory for what? For our file path, so that it will be able to store, like we'll be able to assign all these things to file path without having an issue with our space. So we just use malloc. There's a string length. So we are calculating for the length of the entire array, or possibly the entire string that the user imputed. Then we also calculate for the string length of our path token. So the path that we tokenize, which is the first path, we want to actually calculate for its entire length. So how many characters does it contain? Then after, we need to add extra bytes to it, because we'll add the null terminator and also add this /. So these are the extra characters that we are adding. So that's the reason that we are adding the 2 here. Okay. Now after that, we'll just raise a condition to see if our path token is null. It's not null, all right? If it is not empty, then we want to copy our path token to file path. That means that our directory, that we got, we want to copy it to file path. Then after that, we will concatenate. That means that we will merge / to what? To our file path. All right. Or possibly in other words, we say that we will what? We will add / to what? To our file path. Okay. So maybe if our file path is / bin, all right, then we will need to add / to it. So it will be / bin, then /. Then after that, the name of our program or the name of our command, we want to add it also to our file path. So we are concatenating all these things to our file path. So after that, we'll add the name of our command. So maybe in other words, ls. Then that means that ls will be attached to /. So you will see /bin, /ls. Then we'll end it with a null terminator. All right. Once you're done, we want to actually find out and see if the file path, that's the program, let me say, the path that we have, including the location to that particular program, if it does really exist, okay, then we want to return our file path. And that's what we are going to use to run execv. All right. So if it is not valid, if it doesn't exist, then we want to continue on with our tokenization. And we know that once we tokenize our path, or possibly our buffer for the first time, we need to pass the string, or possibly, yeah, we need to pass the string. Then the additional tokens that we need to call them over and over again, we need to pass null instead of passing path, or possibly buffer again, or possibly the string again. We need to pass null for the subsequent ones. All right. Okay. So this will help us to break off each and every single path. All right. Whilst we are attaching the command and this / and the new line, the null character to it, so that we'll be able to know that, and we'll be able to find which particular directory the command is located in. So this is the simple algorithm that allows the execv to look through your environmental variable, which is the path, to find or possibly to locate that specific command that you executed or possibly that you passed. Okay. So now, once that is done, so if it is true that the path exists, then we want to return file path. So file path will actually return to path. Then after that, we'll return this to our main function. You understand that? So return path to our main function. So that means that the last path that we'll return is actually the path that leads to our program. All right. I believe that is answered. All right. Okay. Yeah. Please, any further question again? Okay. So if there are no further questions, I think we've closed for the night. It has been a very tough night, and it has not been easy though, but it's cool and it's nice.
I think
All right.
the memory leak, we can use Vagrant to identify exactly where the problem is.
Yeah, you can even utilize GDB, a debugger, right, to actually debug it to identify the memory leak. But if even with that, Chairman, it's not really that easy. Yeah. But anyways, since it's the implementation and the general concepts overview, that is the most important thing. Yeah, we've been able to deal with that. And I believe everybody have a fair idea of how to implement the simple shell project. Yeah, and that's the emphasis now. Yeah.
Seth, some of us joined late. I hope you have the recording so that I can keep it through.
So though, even the one you sent yesterday, I think I couldn't open it. That's what I'm saying. Like you can't. Which application is that? Which application is that? Like you used to compress all. Okay.